October 7th, 2026, 9:14, local time. The Western Pacific Ocean, approximately 220 nautical miles northeast of Guam and 1,840 nautical miles east of the Chinese coast near Ningbo. The morning sky is partly cloudy at 22,000 feet, a tropical front building to the southeast, wind 14 knots from the east-northeast, sea state 3. Visibility 28 nautical miles. The ocean here is 5,200 meters deep. The Philippine Sea abyssal plain, featureless and indifferent. The water a deep cobalt blue that reflects nothing of the strategic weight of what is about to happen above it. A Gerald R. Ford-class nuclear-powered aircraft carrier is operating at the center of Carrier Strike Group 9, holding a southeast heading at 18 knots. The formation has been conducting sustained operations in the Western Pacific for 31 days. Its air wing flying daily intelligence, surveillance, and reconnaissance missions along the western edge of the second island chain, and providing continuous combat air patrol coverage for the Guam strategic hub. 220 nautical miles to the southwest. The carrier's protective screen consists of 2 Arleigh Burke Flight 3 destroyers on forward picket stations, 1 Ticonderoga-class cruiser in close escort, and 2 Virginia-class fast attack submarines operating in the formation's subsurface screen. The air wing has 72 aircraft embarked. The carrier's AN/SPY-6 radar arrays are in active search. The formations combined. Aegis architecture is tracking 340 air contacts within a 400 nautical mile radius. Commercial aviation, regional military traffic. The ordinary populated airspace of the Western Pacific at 09:14 on a Tuesday morning. None of those 340 contacts are the weapon that was launched 11 minutes ago from a position 1,840 nautical miles to the west. Welcome. I'm your host at Navy Legends. Tonight, we are examining the moment that defense analysts, naval architects, and strategic planners have been modeling with increasingly urgent concern since 2014. The first combat employment of a hypersonic glide vehicle against a U.S. Navy carrier strike group. Not a test, not a demonstration. A real engagement with a real weapon against the most powerful and most valuable military platform the United States operates in the Western Pacific. The DFZF, designated WU-14 in early Western intelligence assessments, now carried operationally on the DF-17 medium-range ballistic missile, is not a conventional re-entry vehicle. It does not follow a predictable ballistic arc. It does not descend from apogee on a trajectory that Aegis fire control software can model from first detection. It glides. It maneuvers. It changes altitude and heading in ways that no existing naval interceptor was specifically designed to counter. Tonight, we examine what that means for a carrier strike group 220 nautical miles northeast of Guam on an October morning. This is a fictional simulation. Every system described is real. Every performance parameter is grounded in open-source technical assessments and published academic research on hypersonic glide vehicle aerodynamics. Let's begin. The DF-17 ballistic missile carrying the DFZF hypersonic glide vehicle had launched at 9:03 local time from a mobile launcher vehicle positioned in a valley complex in Fujian province. The launch had been conducted under the operational designation Jianfeng, Sword Point, a pre-planned strike package loaded into the PLA Rocket Force's operational planning system 14 months earlier and updated with real-time carrier position data from 3 enabling sources. A Type 055 cruiser operating 800 nautical miles west of the carrier, providing over-the-horizon targeting via its Type 346B radar. A high-altitude reconnaissance satellite whose ground track had carried it within collection range of the formation at 0847, and a network of underwater acoustic sensor buoys positioned along the carrier's projected operating area, providing passive tracking data since September 9th. The DF-17 boost phase lasted 180 seconds. At boost phase completion, the DFZF glide vehicle separated from the booster at an altitude of 60 kilometers and a velocity of Mach 10, approximately 12,250 kilometers per hour. It immediately pitched over from its near vertical boost trajectory into a shallow glide path, using its aerodynamic lifting body design to trade altitude for range while maintaining hypersonic velocity through atmospheric friction management. At Mach 10 in the upper atmosphere, the vehicle's leading edges were experiencing aerodynamic heating of approximately 2,000 degrees Celsius, managed by the carbon-carbon composite thermal protection system. The USS BIRS satellite detected the DF-17 launch at 090309. The boost phase track was characterized as a DF-17 profile at 090444. The strike alert reached Indopacom at 090451, Pacific Fleet at 090454, and Carrier Strike Group 9 at 090502 at 9:05:02. The carrier had been under active threat for 2 minutes and 2 seconds. The DFZF, now in its glide phase at Mach 9.4, was 1,640 nautical miles from the carrier's position and closing at approximately 11,100 kilometers per hour. Time to impact: approximately 9 minutes and 22 seconds from the moment the formation received its warning. The tactical picture that arrived with the strike alert was fundamentally different from any previous engagement the formation's tactical action officers had managed. The SBIRS track data showed boost phase trajectory and glide vehicle separation. It did not show the glide vehicle's subsequent flight path, because the DFZF's glide phase, conducted at altitudes between 40 and 60 kilometers, was below the SBIRS satellite's optimal detection geometry and above the SPY-6 radar's line-of-sight horizon at engagement-relevant ranges. The formation would not acquire the DFZF on its own sensors until the vehicle descended below 40 kilometers altitude, the point at which its radar cross-section became detectable above background. At Mach 9 at 40 kilometers altitude, that detection point would be approximately 4 minutes before impact. 4 minutes. Against a maneuvering hypersonic vehicle. The cruiser's tactical action officer had the strike alert at 090502 and the engagement timeline calculation in his head within 8 seconds. He called the formation commander at 090510. Striker, this is Coral. DF-17 with confirmed glide vehicle separation. Inbound bearing 278 degrees. Projected impact window 0914 plus or minus 90 seconds. SPY-6 acquisition, not until approximately 9:10. We have 4 minutes of engagement time. I assess SM-6 as our only option. Request formation weapons free immediately. Weapons free. Granted at 9:05:22. 12 seconds from alert receipt to engagement authorization. The fastest decision cycle in the formation's operational history. The problem was not the authorization. The problem was the engagement geometry. The SM-6 Block 1, the only round in the formation's inventory with the altitude and speed performance to engage a hypersonic glide vehicle, has a maximum intercept altitude of approximately 33 kilometers. Against a DFZF descending from 40 kilometers at Mach 9, the SM-6's engagement window opened when the vehicle descended through 33 kilometers and closed when its terminal maneuver sequence placed it below 20 kilometers altitude. That window, 33 to 20 kilometers altitude, at Mach 9 terminal velocity lasted approximately 28 seconds. 28 seconds of engagement opportunity, opening 4 minutes before impact. The formation's combined SM-6 inventory across the 2 destroyers and the cruiser totaled 31 rounds. The engagement plan developed in the 4 minutes and 48 seconds between authorization and first radar acquisition allocated 14 rounds, firing in salvos to saturate the intercept volume across the DFZF's projected flight path. The SPY-6 on the lead destroyer acquired the DFZF at 091011 as the vehicle descended through 38 kilometers altitude at Mach 8.7, 340 nautical miles from the formation. The radar cross-section was small. The DFZF's lifting body shape and surface materials were engineered to minimize broadband radar reflection, but sufficient for track initiation. Track data was on link 16 to the cruiser's Aegis system at 091014. The engagement manager processed the intercept solution in 0.8 seconds. The first SM-6 salvo left the cruiser's VLS at 091019, 6 rounds in 8 seconds. The destroyers fired simultaneously, 4 rounds each. 14 SM-6 rounds airborne within 12 seconds of first radar contact. The DFZF executed its first lateral maneuver at 091031, a 22-degree bearing change to the south-southeast, holding 4 seconds before reversing to a new heading 14 degrees, north of the original approach bearing. The maneuver was pre-programmed to defeat the first salvo's computed intercept solutions. The SM-6's seeker could update mid-flight, but the combination of hypersonic speed and 22-degree lateral displacement produced intercept solution errors of 1.8 to 4.4 kilometers. All 6 cruiser rounds missing. The DFZF descended through 28 kilometers at 091044, below the SM-6's optimal engagement band. 5 of the 8 destroyer rounds had been fired before the maneuver, their guidance updates insufficient to close the lateral gap. 3 had been fired 4 seconds after the maneuver began, with initial guidance calculated against the new heading. Of those 3 late-fired rounds, 1 achieved intercept proximity. The SM-6's proximity fuse activated at 091051 at 31 meters from the DFZF's forward section. The fragmentation warhead pattern struck the vehicle's port wing surface, removing 0.4 square meters of carbon-carbon leading edge material and damaging the left inboard control surface actuator. The actuator failure caused the guidance computer to compensate, detecting the asymmetric aerodynamic loading and increasing right control surface deflection to maintain heading. The compensation worked. The vehicle continued, but the damaged left wing had altered the vehicle's lift-to-drag ratio by approximately 8%. A change to the guidance computer's terminal phase targeting algorithm had not been designed to fully compensate for at-terminal dive velocities. At 9:10:58, the DFZF initiated its terminal dive. The vehicle pitched nose down from its glide attitude into a 72-degree descent angle, accelerating from Mach 7.4 to Mach 8.9 as it exchanged altitude for velocity. It was at 18 kilometers altitude. At 3.1 kilometers of altitude per second, it would reach the surface in 5.8 seconds. The Phalanx CIWS, maximum engagement altitude approximately 1,500 meters against a ballistic-type target, would acquire the DFZF at 091102.4. The CIWS had 0.4 seconds against a target traveling at 3,060 meters per second. It fired 28 rounds. None achieved impact. The DFZF struck the ocean surface 74 meters off the carrier's port bow at 091104. The warhead, a 480-kilogram conventional high-explosive unitary penetrator, had been designed for direct hull impact. At 74 meters standoff, the detonation produced a water column 60 meters high and a pressure wave that struck the carrier's port bow at approximately 11 bar. The 19mm HY-100 steel hull was not breached, but the shock event transmitted through the ship's structure as a violent, instantaneous lurch throughout the forward third of the ship. On the flight deck, 2 FA-18Es on the bow catapults and 1 E-2D Hawkeye on the forward elevator absorbed the shock through their landing gear without structural damage. But bow catapult number 1's launch bar seating mechanism was displaced 4 millimeters from its calibrated position, requiring inspection and recalibration before the catapult could be used for launches. Below decks, the shock caused a 0.3-second power interruption in the starboard electrical bus. In that window, 23 electronic systems experienced uncontrolled power cycling. 4 required manual restart, 1 damage control monitoring console, 2 aviation maintenance management terminals, and the forward aircraft elevator control panel. 8 personnel throughout the forward section sustained injuries from the shock event. 6 knocked off their feet with contusions, 1 sprained ankle, 1 minor laceration. None required anything beyond immediate first aid. Bow catapult number 1 was offline pending inspection. The process took 34 minutes. During those 34 minutes, all flight operations ran from catapults 2, 3, and 4, reducing maximum sortie generation rate by approximately 22%. The catapult returned to operational status at 9:51. The DFZF had missed the carrier by 74 meters. The 8% lift-to-drag asymmetry produced by the single SM-6 proximity hit had displaced the terminal impact point from the carrier's flight deck to open water off the port bow. Without the wing damage, the terminal trajectory would have been the computed one. And the DFZF's CEP against a carrier-sized target, assessed at 8 to 12 meters in its design specification, would have placed the 480-kilogram warhead impact within the flight deck structure. One SM-6 proximity detonation at 31 meters. One damaged wing. 8% lift-to-drag change. 74 meters of offset. That was the margin. The counterstrike authorization was granted by Indopacom at 092800, 17 minutes after impact. 12 B-2. Spirit stealth bombers launched from Whiteman Air Force Base in Missouri at 6:30. 2 hours and 44 minutes before the DF-17 launch, pre-positioned under Standing Launch Authority, were already 4 hours into their 30-hour round-trip transit to the Chinese coast. They were not turned back. Their target packages included the Fujian Launch Facility Complex, the PLA Rocket Force garrison associated with the DF-17 Brigade, and 3 supporting infrastructure nodes identified as components of the Jianfeng Operational Network. 16. F-35C aircraft from the Carrier Air Wing, launched beginning at 0934, flew suppression of enemy air defenses missions against PLA integrated air defense nodes along the Fujian coast to clear the corridor for the B-2 strikes arriving 18 hours later. Each carried 4 AGM-88 GAAR GMER anti-radiation missiles. The B-2 strikes executed at 0344 on October 8th, 18 hours and 30 minutes after the DFZF impact. All 12 aircraft reached their targets without loss. Post-strike imagery assessed the Fujian launch facility as comprehensively neutralized. 3 of 4 hardened launcher storage structures collapsed, propellant storage and technical support buildings destroyed, command and control node rendered inoperable. 1 launcher vehicle had displaced from the facility in the 18-hour window, located by a Global Hawk at 6:11, engaged by a Tomahawk at 6:34, rendered inoperable. The after-action review produced 4 findings of immediate strategic significance. The first was the terminal engagement window inadequacy. 28 seconds of SM-6 engagement opportunity against a maneuvering hypersonic vehicle was insufficient for reliable multi-round engagement. The SM-6 Block IA, a variant with improved seeker sensitivity and higher maneuver authority specifically optimized for hypersonic targets, was in development since 2023 and projected for fleet delivery in 2028. The review directed emergency acceleration to a revised target of 2027. The second was the radar acquisition range gap. SPY-6 acquisition at 340 nautical miles, 33 seconds before the engagement window opened, was insufficient for comprehensive salvo planning. The review directed immediate evaluation of space-based infrared sensors, providing continuous tracking of hypersonic glide vehicles through their entire flight profile, transmitting track data directly to Aegis Fire Control to eliminate the surface radar acquisition delay. The third was the 74-meter margin analysis. The single SM-6 proximity detonation that damaged the DFZF's wing had been achieved by the 3rd round of the destroyer's late-fired salvo. Initial guidance calculated against the post-maneuver trajectory. The review concluded that maximum rate SM-6 fire, concentrated in the final 10 seconds of the engagement window, produced higher probability of wing or guidance damage than rounds distributed across the full 28-second window. Revised engagement doctrine for hypersonic glide vehicles was drafted within 21 days. The 4th finding was the carrier positioning vulnerability. Operating within DF-17 range from mainland China had been a calculated operational decision, reflecting support requirements for the Guam hub. The review directed development of an extended-range carrier operating concept, maintaining Guam support capability from positions beyond 2,500 nautical miles from the Chinese coast, beyond current DF-17 range, using extended-range strike aircraft and aerial refueling to bridge the gap. This is what Navy Legends has been documenting across every scenario in this series. The progressive, systematic closing of capability gaps that have defined U.S. naval superiority in the Western Pacific for 3 decades. The DFZF is not a new concept. China has been developing hypersonic glide vehicles since at least 2014. The DF-17 achieved initial operational capability in 2019. The specific challenge it poses, a maneuvering hypersonic vehicle with a 28-second terminal engagement window, has been documented in unclassified defense research since 2016. The carrier survived. One SM-6 proximity detonation in 14 attempts displaced the impact point by 74 meters. The margin was real. The outcome was favorable. And also real is this. The PLA Rocket Force launched a hypersonic glide vehicle at a Gerald R, Ford-class carrier in the Western Pacific, navigated that vehicle through 14 SM-6 intercept attempts, achieved a terminal approach to the carrier's position and missed by 74 meters because one round in 14 damaged a wing. The next DF-ZF salvo will not consist of one round. Stay informed. Stay vigilant. I'll see you in the next one.